So hello everyone and welcome to Wallah guys. Hope you all are doing well and your preparation is going to up to the mark. And if my voice is clear, if audio video is clear, then please let me know. Okay. If everything is clear, please let me know. So guys, in the last class we have Yes. So in the last class we have just covered that is the periodicity of a signal, and in today's class we are going to cover that's a discrete time periodicity. In the last class I told you that which signals you consider it to be periodic and what is basically the meaning of periodicity. Okay. Then we talk about the continuous time periodic signals and we talk about the discrete time periodic. We have to cover discrete time periodic signals. In the last class we also covered that's the real exponential signals, in which I talk about the umbrella functions and all. Now if my voice is clear to you, please let me know so that we can start the today's class, which is one of the most important class. And in this class we will talk about first discrete time periodicity, and then we talk about the energy and power signal. Mind it that energy and power signals is one of the very important class from which you will get definitely at least 1 marks or 2 marks, okay, in your GATE examination. So before with no delay, let's start the class. Hello Anurag, hello everyone. Let's start now. Okay. So the previous lecture was first we cover that is real exponential, and then we covered continuous complex exponentials, in which we covered CTS periodicity. In which we covered that is CTS periodicity. Okay. Now in today's class what we are going to cover? We have to cover first DTS periodicity, and then we will cover energy and power signal. So this is the topic that we are going to cover in today's class. Let's start now. First let's talk about discrete time periodicity. Say consider a function. Let's say I have x of t, and let's sample this function over nts second to get x of nts. In the very first class I told you that what is the meaning of ts. Here ts is sampling interval. So this is sampling interval. Okay. Now the point is that, see here, I am taking this sampling interval x of nts, and if I normalize, what is the meaning of normalize? That divide the whole axis by ts, then I will get xn. I will get xn. Question is that when you say that this xn is periodic, very good evening Vaishnavi, when you say that this signal is periodic, see here, the signal is periodic if, let's say, if I have xn is equal to x of n plus capital N. Mind it that exact the same definition. exact the same definition as previous was. The previous was x of t when equal to x of t plus capital T. Then I say that this function is periodic. Here, if xn is equal to x of n plus capital N, then this xn is said to be periodic. But what is the most important point is that, listen carefully, when I talk about the t, then t belongs to the real number. T belongs to any real number. So, if I consider t to be equal to 2 pi, or t to be equal to 2, or t to be equal to pi by 3, whatever, it is perfectly valid. Perfect valid. Okay? Perfectly valid. So pi should be, let's say, period of this function. Is it clear? Or 2 pi, 3 pi, or 2, 3, 4, whatever with the period of the function, it's a valid. But when I consider this n belongs to integer. I told you in the discrete time shifting that when you have a shifting factor, the shifting factor has to be integer. N must belongs to integer. That is one of the very, very important point that you have to take care of. One of the most important point you have to always take care of. There is no such integer condition for this t, but there is definitely an integer condition for nothing but my n. So let's take an example. Suppose if I have, example I am saying, suppose if I have e to the power j omega c t is a signal, start from continuous time. I told you that what is the period here? T is equal to 2 pi by omega c in the last class. So this is what the period of this function is. Okay, this is what the period of this function. Fine. So this is t. T is 2 pi by omega c. Let us sample this function. Let us sample this function over NTS. Then what do you will get? You will get e to the power j omega c ts time n. We will say like this. What I am doing is that I am taking, assume omega d to be equal to omega c times ts. So one of the very, very important assumption. What I am doing is that let's assume that omega d is omega c times ts. Then this can be written as e to the power j omega d times of n. Okay. Now ts is a sampling interval, mind it. Ts is a sampling interval, and you know that ts is equal to 1 by fs. Where what is fs? Fs is sampling frequency. I told you in the very first class, sampling frequency. Okay, and what is omega c? I told you just omega c is 2 pi by t. Omega c is 2 pi by t, where t is interval. T is interval of period. T is interval of the period. T is just an interval of a period. Don't confuse with ts and t. Okay, this subscript s denotes that we are doing a sampling here, and this capital T denotes what? It is just an interval of this continuous time period. So this interval is a number, a real number, whatever. Now what I am saying is that, see here, e to the power j times omega dn I have, and when it is period, when it is equal to, okay, it is equal to e to the power j omega d n plus capital N, then this is equal to, then this is periodic in nature. Now listen carefully, then we can write this e to the power j omega dn to be equal to e to the power j omega dn times e to the power j omega d to the power capital L. Now what I am saying is, see, if I am assuming that this to be equal to 1, then left hand side becomes a right hand side. Left hand side becomes a right hand side. And I told you that e to the power j theta in the last class can be written as cos theta plus j sin theta. Okay, cos theta plus j sin theta. Okay, so what I am saying is, listen carefully, that see here, if e to the power j theta is cos theta plus j sin theta, then this whole thing, let me write here, the whole thing can be written as e to the power j omega, e to the power j omega dn can be written as cos of omega dn plus j sin of omega dn. You can write that like this. E to the power j omega dn can be written as cos of omega dn plus j sin of omega dn. Now question again, that what should be minimum values of this omega dn I should place here so that this function becomes a periodic in nature. Now again you will say that if I say, let's change the color, if I say that omega dn is equal to 2 pi, a minimum number, then this omega dn becomes how much? This cos 2 pi plus j sin 2 pi, cos 2 pi plus j sin 2 pi, and hence we will say that this is nothing but my sin 2 pi becomes a 0, cos 2 pi is 1, and hence this becomes a periodic. So what is n? N comes out to be 2 pi by omega d. N becomes a 2 pi by omega d. Now question is that whether this condition alone is sufficient to state the fact that this n becomes an integer. Means, for example, what should be the values of omega d I substitute so that the whole thing becomes an integer? Okay, for this pi has to be removed, number one, and the rational form, p by q form, in which there is a sum q, then this q must be cancelled by a sum factor. You understand my point or not? See, what I want to say is that I want this n to be integer. This is the condition. See, what is the condition? Condition is that n belongs to integer. Now if you want this n to be integer, tell me what measure you will do here. First you have to cancel this pi. Assume that by some means I cancel the pi, but what is the guarantee that it is not in the p by q form, it is a general integer? Now to guarantee that this n belongs to integer, what I am doing is that I am appending a one variable k. What is the k? What is the purpose of this k? See, k is a minimum integer, minimum z, which make n to be integer. Okay, what I am saying is that, hello Pratisha, what I am saying is that this k is a minimum integer which will make this capital N to be integer. Let's take an example, then only you will understand. See here, suppose consider e to the power j 7 pi n, e to the power j 7 pi. Example, if you consider n here, omega d is 7 pi. Here omega d is 7 pi. So that what is your n? This capital N would be 2 pi by omega d into k. So what I am saying is that it is 2 pi by 7 pi, this k. So it is 2 by 7 into k. Point is this, that had this k not present in this expression, then 2 by 7 is not an integer. So mandatory I have to introduce this k. What is the purpose of this k? The purpose of this k to make this whole thing to be integer. So when k is equal to 7, this n is equal to 2. Listen carefully. When k is equal to 7, then n is equal to 2. Mind it that you are free to choose any values of k, provided number 1, k should be minimum. Means if you make k to be 14, then also if you put k to be 14, then 7 to the 14 and 2 to the 4, n becomes a 4 here. If you take k to be 14, point is that that should be not the minimum n. Mind it that k, two conditions you have to satisfy. Number 1, it should be minimum. Why minimum? To make n, to minimum. And minimum, and it should be integer. It should be integer. Non-integer values are not allowed. It should be integer. So this is two basic condition that you have to take care of. So this is the two basic condition that you have to take care of. Very, very important point that you have to take care of, that it should be the minimum integer which make this capital N to be equal to integer. Okay, this is k is equal to 7. Let's take another example. Consider, let's say xn to be 4 sine 3 pi n plus pi by 4. Find period n, find period n, find n. Easy you can find. See, what is n? N is 2 pi divided by 3 pi into k. So n should be 2 by 3 into k. And when k is equal to 3, I told you that any value of k you can choose, provided it should be minimum. It should be as minimum as possible and it should be integer. So k is equal to 6 is not the valid value for the k. Why? Because if you put k is equal to 6, then 3 2 just 6. Okay, it will be cancelled, but again n becomes a 4. So I want this n to be 4, n to be minimum, so n becomes a 2. Any values of k is possible. But let's consider a very interesting thing. Very interesting thing here, that hello, that what I get, n is equal to 2 pi by omega d into k. This means that n by k, which is 2 pi by omega d, must be in the form of p by q. That is a rational number. Hello, very, very important point. What is the meaning here? That this n by k, or you are saying that 2 pi by omega d must be a rational number. What is a rational number? Rational numbers are in the form of p by q, where p comma q belongs to integer. Q should not be equal to 0. Q should not be equal to 0. Now to make this a rational number, this omega d, very, very important point I am writing, must be function of I must be function of pi. One of the most important observation that you have to take care of. What I saying? What I am saying, see here. I am saying that if you consider, let's say, if you consider sine 3t, sine 3 pi t, e to the power j 3t cos 7 pi t, they all are periodic. All are periodic. Why? If you consider the capital T here, then T is 2 pi by 3, perfectly valid. T is 2 by 3, perfectly valid. Again T is 2 pi by 3 and T is 2 by 7, perfectly valid. That is omega D here is 3, omega C, sorry. Omega C is 3, omega C is 3 pi, omega C is 3 and omega C is 7 pi. Mind it that they all are in radian per second, okay? Radian per second. It is in second. I'm not writing the unit, but please make a habit of writing unit also. They all are periodic. But let's consider this one. See, sine, if I consider sine 3n, sine 3 pi n cos, sorry, e to the power j 7n, e to the power j, let's say cos 8 pi n plus 3 pi by 4. Hello Amrita. The omega d here is 3. So n is 2 pi by 3 into k. Now, what is the value of n I am allowed to choose? I am allowed to choose only integer values of k. Yes or no? Integer values of k I am allowed to choose, and there is no such integer which will cancel this pi. This means that it is a non-periodic. Non-periodic. Here omega d is 3 pi and hence n is 2 pi by 3 pi into k, and hence it is a 2 by 3 into k. So n belongs to 2. We never write k value we assume in our mind. So n belongs to 2. Here omega d is 7. Again n is 2 pi by 7 into k, and this time again it is a non-periodic. Here omega d is 8 pi and hence n is 2 pi by 8 pi into k. Mind it, before choosing the values of k, it should be in a what? There is no common factor. It should be in a pure rational form. What is the meaning of pure rational form? There should be no common factor between them. So you have to remove the common factor. Again with the same fact, 1 by 4 times k, and hence n is equal to 1 for k is equal to 4. If you straight away choose pi cancel, if you straight away choose k to be equal to 8, then n becomes a 2. Again it is not a valid thing. So n should be minimum, n should be minimum. This is what the most important point that you have to take care of, and for this you have to remove all the common factors. All the common factors. You understand my point or not? So this is what the most important. Now listen carefully. See, when I talk about the omega c 3, 3 pi, 3, 7 pi, all are valid. But when I talk about omega d 3 and 3 pi, this is not valid. Not valid. This is valid. This is not valid. This is valid. You understand my point or not? So when I talk about the omega d must be function of pi to have a finite integer, finite, let's say, period for a discrete time functions. This all this phenomena arises because of the fact that this n belongs to integer. Mind it that this is the constraint which create so many constraints on omega d also, on k also, everything, and minimum integer, not just the integer, it should be the minimum integer. You understand my point? This should be function of pi. This was a gate question minded. N by k is what? A rational number, p by q, in the form of p by q. Very, very important point. Okay. Now again, exactly the same thing. Suppose I have, let's say, xn, which is the combination of x1n plus x2n plus x3n plus x4n and so on and so forth. Okay, and this have a omega d1 finite, omega d2 finite, omega d3 finite, omega d4, or you will have, let's say, n1 finite, n2 finite, n3 finite, n4 finite. Last class question, that what is the common period? First check that whether the periodicity exists, whether question is that whether xn is periodic. If yes, what is common n? What is common n? Whether this function is periodic, if this function is periodic, and if it is periodic, then what should be the common n? Listen carefully. It is periodic. It is periodic. Let's say in this way, xn is periodic if LCM of n1, n2, n3, n4 and dash dash exist. Again the same thing. In the last class, I told you the same thing for T1, T2, T3 LCM exist. Yes or no? And common period is common period is same LCM of n1, n2, n3 up to n, let's say, k, whatever. So the common period is, take the whole LCM. Yes, explain this with example. I will explain it. Let's take it. Example. Suppose I have a xn to be equal to, let's say, sine of 3 pi by 5n plus pi by 4 plus 6 cos of 8 pi by 7n plus 9 sine of 9 pi by 5n plus pi by 4. Yes, I am giving you the example. See, suppose someone asks you find period. Find period. Let's find out the period of this function. See here. Here n1 is 2 pi by 3 pi by 5 into k. N1 is 2 pi by 3 pi into k. So what is N1? N1 is 10 by 3 k, and when k is equal to 3, this N1 is 10. Very simple. N2 is 2 pi by 8 pi by 7 into k. So it is a 14 by 8 into k, or you will say you have to remove the common factor. So 7 by 4 into k, and hence when k is 4, directly I am writing n2 to be 7. N2 is 7. Similarly here n3, 2 pi by n pi 9 pi by 5 into k, and n3 is how much? It is 10 by 9 into k, and n3 again is 10. Now what is the common n? Common n. That is common n is LCM of 10, 7, 10, which is 70. So the period of this function, is nothing but my 70. Is there any other method? Yes, omega method is also valid here. Let's take the omega method and take the GCD of this function. Omega method, GCD of this function. Omega method is what? Omega 1 is, consider omega 1 to be 3 pi by 5. 3 pi by 5. Omega 2 is 8 pi by 7. And omega 3 is 9 pi by 5. So take GCD, omega d naught. How you will find out omega d naught? GCD of 3 pi by 5, 8 pi by 7, 9 pi by 5. So it is GCD of 3 pi, 8 pi and 9 pi divided by LCM of 5, 7, 5. What you will get? See, GCD is the highest common factor which divided by integer data values. So what is the highest common factor here? It is a pi. So it is pi divided by, and LCM of this is 35. So omega d naught, change the color, omega d naught comes out to be pi by 35. What is the n? N is 2 pi by omega d naught into k. So this should be n is equal to 2 pi by 35 into k, or it is 70k, and when k is equal to 1, n belongs to 70. So the same thing you will get 70 from here, 70 from here. I think this is the very standard method we will opt throughout our course. In Fourier series also, when I talk about the CTFS, that's continuous time Fourier series, and DTFS, discrete time Fourier series, then this is the method I will use to define the fundamental frequency and everything. Okay, fundamental frequency and everything. Sorry for the disturbance. Okay, now so this is what my complete periodicity function is. So this is what a periodicity representation of this function. So we talk about continuous time periodicity and discrete time periodicity as a whole. Okay, so we talk about the continuous time periodicity and discrete time periodicity as a whole. Now our next topic is energy and power signals. What do you mean by energy signals and what do you mean by power signals? Listen carefully. See here, you talk about, let's say, okay, sorry for the disturbance, guys. You talk about, let's say, for example, a signal area under the curve. Area under the curve is a measure. Area under the curve is a measure for, let's say, defining the one characteristics of a signal. Okay, so area under the curve is a measure which defines one characteristics of a signal. Similarly, energy, let's say, is a measure. Energy and power is a measure for ability of a signal to transmit, if it transmit into the bare channel. For example, in communication system, from source end you are transmitting a signal, okay, to destination. How much energy it has so that it travel a particular destination without affected by a noise. That's what the meaning of energy is. So energy in a very simple sense is the ability to do work. Exactly in the same sense, let's, for example, if I have a system, if I have a system and if I'm, let's say, transmitting a particular signal here and I'm receiving the signal at, let's say, destination in, then this is the source in. Let's say this is the source in and that is destination in. This is the destination in. So what is the ability of a particular signal to transmit from source in to the destination in? Okay, that's what the energy is. In very simple sense, see here, if suppose, for example, this is the x of t, if we have x of t, then the energy is given by this way. Energy is what? It is the minus area in the curve of a signal with its complex conjugate dt. See here, why, if we have a signal x of t and if you multiply the signal with its complex conjugate and then take the area in the curve, then this is what my energy of this function is. Energy of any signal x of t. But question arises that why we are multiplying the x of t with x conjugate of t. See here, if we have, let's say, j7 example, and if I multiply it with a minus j7, then don't you think that I will get minus j square 49, and j square is itself a minus 1 and hence it is 49. Example 1. Example 2. Let's consider 3 plus j4 multiplied with 3 minus j4. You will get 9 minus j4 whole square, which is 9 plus 16, and comes out to be 25. In both these example, one thing is very clear, that when you multiply the function by its number by its complex conjugate, then it becomes a real. Yes or no? See, when I multiply the function with its complex conjugate, it becomes a real. So what is the purpose of multiplying the function with its complex conjugate? To make this function to be real. In tomorrow class, I will tell you that in general, the function is complex in nature, whose complex conjugates are defined. And when you add the signal with this complex conjugate, then you will take the function back. You will get your x of t. So what I am saying is that when you multiply with the function with xt with your x conjugate t, x of t with x conjugate of t, then this whole thing, okay, this whole thing becomes a real. This whole thing becomes a real. And energy is nothing but my area under the curve of a real signal. So that's what the point why we have to multiply the function with its complex conjugate. Now, but for real signals, we know that xt is equal to x conjugate of t. Xt is equal to x conjugate of t. If xt is equal to x conjugate of t, okay, then this thing can be written as, the energy can be written as minus infinity to infinity mod, let's say, x of square of t dt. Or you will say, you can write this as also minus infinity to infinity mod xt. If xt is in general complex, then take the mod of that and then take the square. For example, if you have a 3 plus j4, it is mod 3 plus j4 is what? Is root 3 square plus mod is 3 square plus 5 square. Yes or no? And it comes out to be 4 square, sorry. It comes out to be 5, and when you take the 5 square, it is 25. It is exactly same as 3 plus j4 multiplied by 3 minus j4. Just I told you. Comes out to be 25. So you will write either in this form or write in this form. All have a meaning same. Both are same. Both are same. And for real one, you have this one. Okay? So this is what my energy representation of a function. This is what my energy representation of a particular function. Okay, fine. Now, if energy is clear, let's take find out the energy. Find energy. Find energy for e to the power minus alpha t ut. In the last class, I told you that what do you mean by e to the power alpha t here? E to the power alpha t ut is a function which is denoted by this one. See, this is e to the power minus of alpha t ut. Let's find out the energy of this function. How you will write? Energy is, since alpha belongs to real, for example, alpha belongs to real. So energy comes out to be minus infinity to infinity e to the power minus of alpha t into ut, and since it is real, so there is no such complex conjugate, exactly multiplied with the same signal, e to the power minus of alpha t ut, and we have a dt, okay, and because of ut it is 0 to infinitive e to the power minus of twice alpha t dt, it is 1 by 2 alpha e to the power minus infinitive minus 1, so it is 1 by 2 alpha joule. That's what my energy is. Energy is in joule. It's very simple. But let us consider, this is example number 1. But let us consider another example, example number 2. Example number 2. Okay. See here, it is, let's say xn is, no, not xn, xt is, let's say e to the power j omega ct. Xt is e to the power j omega ct. Now if xt is e to the power j omega ct, listen carefully, then this is a complex function. This is a pure complex function. And how you will write? You will write energy as minus inverted to infinitive xt into x conjugate t dt, which can be written as minus inverted to infinitive e to the power j omega ct e to the power minus j omega ct dt. Complex conjugate of this function is minus j omega ct, and this comes out to be minus inverted to infinitive. See, base are same, power will add it, e to the power 0 dt, which is minus inverted to infinitive 1 dt, and hence it comes out to be infinity. What's the meaning here? Listen carefully. See what it says. It says that e to the power j omega ct, e to the power j omega ct have infinite energy. Is it possible that any signal have infinite energy? If any signal have infinite energy, this means that if you send a particular signal from one end of the universe, then it will reach to any other end of the universe. But practical shows that your voice will not reach even a distance of 10 meter or 20 meter. It's not possible, no matter how much you shout. Yes or no? This means that this, exactly for these kind of signals, the representation in this form to find out the net weight is not clear, okay? Not okay. So what I'm saying is that let us consider how to handle the energy concept for these kind of signals. Let us take this one. See here. Suppose what I'm doing is that, see here, let us consider a signal which is number 1, infinite duration, and finite amplitude signal. Let us consider two kind of signals, two characteristics of a signals as a whole. Suppose I am taking a signal which is everlasting first, and the amplitude is finite. Amplitude is not equal to infinity. What I am doing is that, let us for example restrict this over the bound, okay, and I am finding the energy here. Yes. and so on. What I'm doing is that I'm finding energy in this region. Let's consider this region to be minus t by 2 to t by 2. Let's take a bar from minus t by 2. You may take any bar, but let's consider a symmetrical bar between minus t by 2 by 2. What I'm doing is that between minus t by 2 to t by 2, I am finding the energy xt into x conjugate t dt, okay, and then divided by the whole bar. What is the whole bar? See here, what's the gap? The gap is this one. See, the total gap is t. So dividing by t, and since I have taken up to this much, up to this minus t by 2 by 2, and I have to take the whole extent, so what I'm doing is that I am taking this t tending towards infinity. What I did, I first restrict the signal over minus t by 2 by t by 2. Let's find out the energy over this extent, then divide it by the bar that I have taken, and let the bar tending towards infinity. Exactly the same thing, but this measure, I'm denoting it by a new name, which is denoted by a power. So power is basically energy per unit time. See here, power is energy per unit time. Question is that, let's check that whether this theory is applicable in this signal or not. Let's do it. So our example was this one. See here, our example was x of t to be equal to e to the power j omega ct, and let's find out the power of the signal instead of finding energy. So what I'm doing is that, see, power can be defined as 1 by t minus t by 2 to t by 2 with the t tending towards the infinitive, e to the power minus of j omega ct, sorry, e to the power j omega ct. Okay, let's first define what is power. Xt into x conjugate t dt, and hence power comes out to be 1 over t with the t tending towards the infinitive, t tending towards the infinitive, minus t by 2 t by 2. So it is e to the power j omega ct, e to the power minus j omega ct times dt, and what it will, p is equal to 1 by t with the t tending towards the infinitive. It is a minus t by 2 to t by 2 1 times dt. Now when you solve this limit, what you will get? You will get t over t with the t tending towards the infinitive, and hence it is a 1 watt. So that is what the point is. See, this signal is perfectly power signal, not the energy signal, and that is why the power comes out to be 1 watt, energy comes out to be infinity. Energy comes out to be infinity. That's one of the most important thing that you have to take care of. So is there any relationship between energy and power? Yes, of course we have. So our next is relationship between energy and power. What is the relationship between energy and power? Let's define. We define the power to be equal to 1 by t minus t by 2 to t by 2 xt into x conjugate t times dt. Xt into x conjugate t times dt. Okay. Yes. And p into t, what I'm doing is that multiplying t both the side, and let t tends to infinity. What I'm doing is that, see here, p into t with the t tending towards infinity is equal to minus t by 2 to t by 2 x of t into x conjugate t dt. And hence, when t tending towards infinity, if I put here also, and look at the limit. See, inside there is a no such t. In the limit, you have minus t by 2 t by 2. So this can be written as minus infinity to infinity xt into x conjugate t dt. And I know that this is our energy. So what the relationship I get? I get energy Ex is equal to power Px into t with t tending towards infinity, or power Px is equal to Ex over t with t tending towards infinity. Yes or no? So these are the two relationships I get. These are the two relationships I get here. Okay, let's write something. So suppose if a signal has a finite power, then if Px is finite, when you put t is equal to infinity, the energy becomes an infinity. What I am saying is that for finite power signal, energy is infinity. If P is finite, energy is infinite. For finite energy signal, the power, see, if energy is finite, when you put t tending towards infinity, it becomes a 0. Power is 0. This is one of the very, very important two expressions we have. Let us circle this, box this expressions. One is this one, and another one is this one. These are the two very, very important representation that you have to always take care of. You have to always take care of. So if a signal is energy, then its power comes out to be 0. If signal is power, then its energy comes out to be infinite. This signal was, see here, this was a perfectly power signal, and hence the energy comes out to be infinite. Now this is a perfectly energy signal. If you take a power, then the power comes out to be surely 0. That's 100% sure. Okay, fine. So this is what we have derived, and for CTS we have derived this one. Okay, so for CTS we say that energy Ex was how much? Minus infinity to infinity xt into x conjugate of t dt. Power was 1 over t with t tending towards infinity minus t by 2 to t by 2 xt into x conjugate of t xt into x conjugate t dt. Okay, so this is nothing but a representation of energy and power in continuous time. Same representation you can represent in a discrete time also. So what is the discrete time representation? Ex is summation n is equal to minus infinity to infinity. Okay, here the what? The integration in continuous time is summation in discrete time. I told you in the very first class. So it is xn into x conjugate n. Xn into x conjugate n. And how to find out the power relationship? Listen carefully. How to find out the power relationship? See here, for this, what I am doing is that, let us consider some discrete time function. Let's say I have this one. This one. Now, what I am saying is that to define the power of a function, we have to restrict it over the limit. So what I am doing is that, let's restrict it over, let's say from here to here, let's say from minus n to n. From minus n to n, I have, for example, from minus n to n, I am restricting it over the limit. So whatever the sample it is, let's say consider it to be 4, consider it to be 4, 4, you have 3, you have, let's say 5, you have minus 2, minus 2, minus 2, minus 4. I am restricting it over the limit minus n to n. Okay, now what I am doing is that, so what should be the power formula? Here the power would be summation n minus n to n xn into x conjugate of n. Okay, and we have to divide it by a whole limit. We have to divide it by whole limit. What is the total limit here between minus n to n? I told you in the width, upper bound minus lower bound plus 1, because we have to consider the zero sample also, no? So divided by a total limit. What is the total limit here? Total limit is, what is the total limit? Total limit should be 1 upon 2n plus 1, not 2n. Why this plus 1 comes? Why this plus 1 comes? Because, see here, because of zero sample. See how many samples I have? 1, 2, 3, 4, 5. If you take minus 2 to 2, total 5 samples you have. So this is 2 into 2 plus 1. So total 5 samples we have. So what I'm saying is, this is from minus 1 by 2n plus 1 with this one, and this should be, n should be tending towards infinitive. Here t tending towards infinitive and here n should be tending towards infinite. So this is what my power formula, this is what a power formula for discrete time. So we have a 4 formulas. One is a continuous time energy, which is this, continuous time power, which is this, continuous time discrete time energy, and discrete time power. So this is 1, this is 2, this is 3, and that is 4. So these are the 4 very important expressions that you have to always take care of while defining the energy and power. Now I'm giving you some examples. Take it as a homework and solve it for energy and power of a signal. So let's take find energy. First is e to the power minus of 2t ut. Second is e to the power 2t ut, e to the power 2t u minus t. Third is, let's say 1 by 2 to the power nun. Fourth is 1 by 2 to the power minus n u minus n minus 1. Fifth is 1 by 2 to the power mod n, and sixth is e to the power minus of 2 mod t. Find energy of this signal. So both examples are there, continuous time as well as discrete time. Okay, let's take a power example also. Find power. So first is A in CDS, B that is 5 in DTS, C is UN, D is A cos of omega ct plus theta, and E is this function. This is e to the power minus of t ut, and that is A. Okay, this is A, this is e to the power minus t ut. So you have to find out the power. And third is find both energy and power. First is then here e to the power 2t ut. Second is t ut. third is an even. So these are the, let's say, 5 example. This is A. 5 example, here 6 example, and here 3 example. So in total I have given you 14 questions in energy and power. Tomorrow we will solve all these questions and we will derive a very important conclusion regarding energy and power, so that by just looking the signals you can tell that whether this is energy or this is power. Okay, so now what we have that is covered in today's class is, first we covered a discrete time periodicity, in which I covered that total n should be 2 pi by omega d into k, and then we covered energy and power of a signal. So the 4 formulas that we have derived. From tomorrow I will start with the problems and I will revise it for a little bit, and then I will cover everything in tomorrow's class. And tomorrow's class we will talk about the symmetry on signals also. Okay, so this is the third part of characteristic signal for tomorrow, and one more part will come. Then after that the complete basics of signals is covered. After that we will start a system. Okay, so I think that this is the whole thing that we have covered till now, is a complete signal formation in 10 to 12 class. 2 more classes is required to cover everything about basics of signals. Then we will start a basic system if time permits, or if there is a regular attendance. Okay, because that's the required. So with this, thank you very much guys. Thank you. If you have a doubt, then do ask the doubt. Whatever the doubt you have, please do write in your comment box. Okay, every time I watch the comment box. And with this, thank you very much. Thank you.